The total amount of energy from outside the solar system ever received by all the radio telescopes on the planet Earth is less than the energy of a single snowflake striking the ground.
The Interplanetary Podcast. The exploration of space for the benefit of all humankind. Your host in Guildford, Matthew Russell.
Oh, yeah, baby Sagan. There you go. That was Carl Sagan, who unfortunately died on this day back in 1996. Bit of a sad one. This is a bit of an odd podcast. I don't have a co-host this week, so I'm just going to leave you with a very long interview I did with a chap called Paul Knight from Goonhilly. Goonhilly being an enormous radio communication site based near Helston in Cornwall. It's a really interesting little chat that I did back in 2018. So I'm going to let Paul explain all about Goonhilly, and I shall see you all after Christmas. So have yourself a lovely Christmas and a kutai.
The Interplanetary Podcast, putting the ace back into space.
So I'm in the lounge with Paul Knight from Goonhilly, just to have a little chat about some of the history of Goonhilly and how it came to be. Yeah. So, where were we? Sorry.
Well, we were just sort of talking about Intelsat and the types of satellites that we used to work to when it was a telecommunications station. And really, Intelsat was the first international satellite organization, and countries had a representative. It's sort of like a United Nations, but for satellites. And countries had representatives and they meet 3 or 4 times a year for what we all thought is jollies, but obviously they did a lot of business. But then again, you never know. And in the early days, the Post Office, or BT as it now is, was the UK representative on the board of Intelsat. So senior management in London of the Post Office were actually members of the organisation. So in the early days, all the satellites we worked to were Intelsat satellites, Eutelsat, and those sort of organisations didn't exist when we first started.
What sort of year was this?
Well, I arrived as a fresh-faced, just finished my training from the telephone area at Goonhilly in 1966, October 66. It's quite a memorable year for those who like football. It was the World Cup, our one claim to fame in the World Cup. For me, the abiding memory I have of that year was the Aberfan disaster in South Wales, when all the kids were killed in that school when the mine slag tip ran down the hill onto the school. And I remember it mainly because at the time it was my last major job in the telephone area before I transferred into what eventually became BT International. And I was involved in circuit provisioning for all the press, the broadcast companies, to get circuits from the newspapers out to Aberfan so that they could run their stories. So it sort of has will always stick in my mind. And then I came to Goonhilly, as I say, as a technician, lowly technician, wondering what I was getting to myself into, but very interested because I'd seen all the television programs with Raymond Baxter and all those people at Goonhilly for the first transmissions. And I decided then that's where I wanted to end. That's where I wanted my career to progress towards. But at the time I was in the telephone area. I had to take tests and stuff like that, exams to move into international. And my boss at the time in Bristol said to me, I think you're a fool. I think it's foolish for you to go to such an out-of-the-way place with technology that nobody knows is going to exist, and back yourself into a corner and not have any prospects, where you could stay here and you could become a TO and stuff, which was a technical officer. Those people who hear this who were ex-BT will know exactly what I'm talking about. Anyway, I decided to ignore him completely and came to Goonhilly, and that was the best move I ever made.
Yeah, I mean, there must have been, I mean, if we're talking about the late 60s, there must have been quite a buzz at the time about space in general, because we've got the moon landings and we've got...
Yeah, and there was Sputnik and all that years gone by, you know. So in the late 50s, 59. So yeah, it was, to me, it seemed if you wanted to get on in a new field of telecommunications, it was the place to go, you know. And I remember the guy saying, "What do you want to get? Do you want your career to be?" I said, "Well, eventually I want to have your job." I said, "Or a job like yours, not necessarily your job, but a job like I want to be your rank," which in those days was an executive engineer. And anybody who worked in the telephone regions and areas, if you saw your executive engineer once a year, that was you remember that for the rest of your life, you know. So that's where I wanted to go. And so as they say, water under the bridge. I actually, when I left, that's what I left as, or the equivalent version of it in the modern parlance. So I came there as in 1966, October 1966. It was still just finishing being an experimental facility. There was still only the one antenna, Goonhilly 1, which is a job I've got. It's come round full circle to haunt me, that thing. But and we were not 24 hours in those days. It was the services operated on a daily basis, shared between the UK, a station in France, and a station in Germany, to one station in the USA, Andover, Maine, in the USA. Both the German and the French station and the American station, Andover, had large horn antennas, and Goonhilly was the only dish type antenna.
Was that an advantage or a disadvantage?
It was an advantage in some respects because it turned out to be the best sort of antenna. It was relatively, I say, cheap to manufacture. The horn antennas were large, huge structures, and they had you needed a huge piece of land to put them on. Not that that was a problem at Goonhilly, although to get it flat to run the track was quite a technical, difficult problem in those early days. I mean, get it to when I say flat, get it to the tolerances that you needed to run a satellite antenna around on a railway track. So yeah, Goonhilly was cheaper to make. It's just lump of steel, really, with a shiny, a radio shiny surface. Yeah, big one, 85 feet in diameter. So it was quite a feat of engineering, done by a husband and co, the same guy who built the Jodrell Bank facilities. In fact, Goonhilly 1, people say, "Oh, that's a copy of the Jodrell Bank." It is and it isn't. It was actually they were going to start to build the Jodrell Bank station, and the government stopped that project and said, "Go and build Goonhilly 1." So Goonhilly 1 is actually the first antenna based on that design.
Are they a similar sort of size, actually?
They are, although the Jodrell Bank antenna is a little smaller. It's also a different shape now because they put, what if you like, large ears on it, and it's more of an oval shape now than it was. Recently, within the last 10 years, I suppose, went through a major refit. Is in pristine condition. Looks like a lovely piece of kit. In fact, I'm going up there next Monday for more conferences on what we're going to do to Goonhilly 1.
Yeah, well, I mean, they have festivals round.
Jodrell Bank's a fabulous place. Yeah, well worth a visit. If you're ever up that way, well worth a visit. We have a superb tourist facility, visitors facility there. And to see the big, what you might call wire telescope, the huge one, which is again a parabolic reflector, but you can see all through it because it's all sort of an open type construction because of the frequencies it receives. It's amazing to see that structure. Absolutely, and when it moves, it's like watching a ballet dancer. It's absolutely fantastic if you're that way inclined. if you're technically inclined, shall we say?
Yeah, well, I definitely do need to get up to Jodrell Bank.
I do. Yeah. I mean, you don't see it move all the time, although they do quite a lot of experiments with it. It all belongs to, also part of Manchester University.
Yeah.
So anyway, I arrived at Goonhilly as a technician, and in those days, every morning we shared it, as I say, with the other two stations in Europe, and your station did 1 week's traffic, followed by a week's maintenance, followed by a week's standby, and then your week traffic, and it needed those sorts of timescales to tweak all your. Once you finished your week's operational services, you had to strip it all down, rebuild all the electronics, the low noise amplifiers, which were a thing called amazers, which were liquid helium cooled devices.
No way.
You know, they had to be refurbished with liquid helium and stuff like that. The helium had to come down from London, came down on the train. We had to go over and collect it from Red Roof Station, bring it back in a Land Rover.
Helium's not cheap either, is it?
No, well, they collected the helium, and they had these big balloons. I mean, huge, great balloons in one of the equipment rooms over there. And as the helium boiled off, it was collected, and then the gas was recompressed and sent back for recompression into liquid helium again.
Oh wow! So they sent it off uncompressed. That must have been.
Yeah.
That must have looked incredible.
A big vat sort of stuff. Yeah, well, not a vat, a big container. Yeah. And then there were two dewars. There was a liquid helium dewer, which was the inner dewer, and around that there was a liquid nitrogen dewer. And the amplifier thing. Device was right in the middle of the liquid helium. That operated around about 15 to 25 degrees Kelvin. So it was.
And that's presumably to get around the noise.
Yeah, to get low noise.
Yeah.
It's getting down towards superconducting and stuff like that.
Yeah,
you know?
I mean, what were you there when that whole system got ripped out and replaced by something more modern, which was able to work at low noise? Or?
In some way. Yeah, I was there then. Yeah, I wasn't. I was then on Goonhilly 2 had been built by then, and I was on maintenance of Goonhilly 2. So I didn't really get involved in what went on for those refits. But there were several refits. I mean, now you can get these Peltier-cooled amplifiers and stuff like that. They operate it down at 20 degrees Kelvin, and there's there doesn't look anything special about them at all.
Right.
They're just expensive.
Yeah.
So that's what we used to do. So when it was your day, it was your start on the Monday of service. Then you would 8 o'clock. You would start, and you'd contact the station in the USA, and you do what they called straightaways, which was you would test between the two stations your carrier to noise ratios and your signal strengths, and send what they called a white noise test set over, and you measure the noise in all the frequency bands associated with telephone conversations, because it was all telephone, it was all telephony. There was the facility to do TV, but if you did TV, then telephony had to stop. You couldn't do both. There wasn't the capacity in the satellite.
Right. And how many satellites were up?
Just the one.
Just the one.
Just the one.
And that was Telstar, was it?
Telstar initially for the first experiments, and then HS303, which was the first commercial satellite. That had a bit more bandwidth.
Right.
Like it had room for 250 telephone circuits or one television channel.
Right.
And so you went you did your straightaways on the first morning, and you, in fact, then you carried traffic, then telephone traffic, then until midnight, and then at midnight you turned the key, and it looped all the circuits back to London so they could monitor the circuits, but there was no traffic. And then 8 o'clock the next morning, you went through the whole process again. You did that for 7 days. And after those 7 days, you handed off to the next station, which in our case was always the French station. They did the same for their 7 days, and they handed off to the German station. And then in the meantime, we were then standby. And if for some reason when they handed off, it didn't go, then it would come back to you. Yeah.
So the people using this telephone service, presumably this isn't your punter use?
It was. Yeah, it was. I mean, STD obviously came in the 50s, and then you could dial the international code then. I think it was probably mainly limited to around London. It was still fairly expensive, so it would be more business orientated than personal. But yeah, you could dial. They were mainly operator controlled. I think in the very early days, so you rang the operator to get your international call. But yeah, it was only Europe to the USA,
right?
Nowhere else. Although it might have gone on, I suppose. No, it probably all terminated in the USA.
Yeah,
I can't be sure of that.
So I mean, there must have been, because the cables come up quite nearby, don't they? When it was undersea cables for the telephone.
Yeah, I mean, well, they all terminated in London, of course. But in those days, it would have been, I think, TAT1 and CANTAT1. CANTAT1 went across from Scotland, I think, across to Canada. TAT1, I'm not sure where TAT1 terminated in the UK, where it came ashore. It was probably Widemouth Bay or somewhere like that. I'm not sure about that. I can't remember. But that was all there was, other than HF radio,
right?
Which was like rugby and those sort of stations.
Yeah.
Where if the atmospherics were not too good, the voice would go all funny and stuff like that. But then in January, the end of January, 67, we went commercial. And that's a date I remember because we got married at the end of January and I was away on honeymoon and I came back to Goonhilly and the first thing they did was put me on night shift. And that was the first time we then went 24-hour shift. And then it was commercial then for 24 hours and we had a full shift rota. And gradually the number of circuits increased as the bandwidth became available, different satellites.
Right.
Until it was the full commercial system we knew. And in fact, when that happened, the price of an international telephone call to the USA, mainly to start with, tumbled. It came right down from several pounds to like 50p,
right,
10 shillings,
Yeah.
10 whole shillings.
So it actually started to become more of a kind of
relatives
phoning each other rather than businessmen.
Well, although there was still, I mean, we had what they called the busy periods, and when the time zones coincided, the daytime parts of the time zone coincided, the traffic used to really zoom up, and then it would tail off into the evenings and early mornings.
Right. So for that entire period, presumably no science was being done at Goonhilly.
No. Science was always being done. There were two groups of people. There was the operational people who worked for. We all worked for the post office, but there was an organization called ETE, which stands for External Telecommunications Executive. And they were the part of the post office that used to have been, if you like, the foreign parts when they were all nationalized in 1947.
Right.
But so they were part of the post office, but they looked after all the external telecommunications from the UK. And then there was the radio department, which was associated with the then research department at Dollis Hill, which later moved out to Martlesham Heath.
Right.
And they became what was known as TD, Technology Development Group, and so that so there always has been or always was a branch of the post office and then BT, which was associated with experimentation and progress. And it was eventually it became my part of my role. It was to head up a team of people to do with radio propagation and electromagnetic compatibility and all those sort of things that came along later. And we did very early development on solid state high power transmitters with contracts with universities for the basic science and stuff like that. And again, in fiber optics, we did a lot of original groundwork in trying to use fiber optics to transmit microwaves rather than just light waves.
Right.
So we converted the radio waves into light waves to travel over fiber optics rather than on coaxial cables. And now that's common throughout the industry.
Yeah. It was something that Eddie pointed out that it went straight into fiber optics.
Yeah, it was all about trying. The thing that drives development, apart from wartime development, is cutting costs.
Yeah,
increasing your revenue at a rate that is by cutting your operating costs.
What big changes did you see because you've been at Goonhilly a long time? So
too long.
What big changes did you see what were the kind of main?
Well, the biggest change of all was the change from analog transmission to digital transmission. I mean, when I started there, it was all analog transmission, and we used frequency modulation to transmit the signals via the satellites. And you started with a baseband signal, which was what were known as groups and supergroups, and they were like basically blocks of 12 channels. And 12 voice channels, and a voice channel is roughly 4 kilohertz wide. So there are blocks of channels, and they were then, as I say, groups were the basic block. Then it went into super groups, which was 5 groups, and then it went into hyper groups, which was 5 super groups. I think it's a long time ago that, and that was all frequency modulated onto it was up converted, went into come from baseband, went into a modulator where it was frequency modulated up to 70 megahertz. Then it was up converted into 6 gigahertz, and then it went through to the transmitter. Transmitters were always located on the antennas, and on a site like Goonhilly, you had a main building where all the what we termed the IF and the baseband equipment was. And you had the antennas where all the low noise amplifiers and all the high powered amplifiers were operated. So we had these big coaxial cables from one across site. And eventually that transformed into not coaxial cables, but into waveguides across site, elliptical waveguides. And now it's been transformed again into fiber optics. Right. And I mean, if you haven't got it here, but an elliptical waveguide would have a diameter of about, I don't know, say in the narrow plane about 2 inches. In that same sort of space, you can get thousands and thousands of fiber optics, each one capable of taking thousands and thousands of channels. And the transmission loss, I mean, we're talking about 600 meters maximum distance. So the transmission loss for a coaxial cable and a waveguide was quite significant. Whereas a fiber optic, the transmission loss is over that such a short distance is virtually negligible. So it means that you can cut down on your operating costs. You don't need so many amplifiers. Amplifiers consume power. Everything changes. Changes in a big way.
Absolutely. When you switched over to digital, I mean, talking in the audio industry, we literally started to switch over to digital radio for handheld microphones and things like that only now because of latency problems.
Yes,
Are
yes.
there the similar sort of latency problems?
There are. I mean, if you deal with computers and transmission things, you get the thing called a ping time.
Yeah.
And the ping time is a significant problem. I mean, it prevents some types of what you might call common transmission of emails and stuff like that. You have to change the way you code it to get over things like long ping times. And if you have like two routes, a main route and a diverse route, if the ping times are not the same on both routes, when there's a changeover and it flops to the other route, there's some sort of, could be that because the ping times aren't the same, there's that brief moment where everything goes off. Yeah. And you have to resynchronize. And if those sort of things happen and you have to resynchronize, then what is to most people would be a short break of less than, say, a few milliseconds. If you then introduce the resynchronization for a very complex long route, it could take minutes, just for that one short break. So you don't want those things to happen, and you have to be very careful. You have to, because we're talking, when we got multiple digital circuits over one route, you're talking availability times of 99.99999, like less than 15 minutes a year outage time, so you can't lose all that sort of 15 minutes in one
hit.
One hit. No.
Yeah. So with over the decades, obviously we've got like 2,500 satellites now up in
Is there?
something like that. Up in. I mean, obviously a lot of them are military, but we've got a lot up in, and I'm assuming a lot of what Goonhilly's been doing is Earth orbit satellites. So have you ever, during the history up until now, have you done any deep space communications with satellites?
No, not as far as I'm aware. I wouldn't say I'm aware of everything. I mean, you never know in this industry. For years and years ago, we pointed at a satellite. There's no, that the beam doesn't go to the satellite and stop.
Yeah.
It continues on. So who knows what other people could modulate on top of that.
Right.
And in fact, going back into the late 70s, early 80s, there were people were experimenting with forms of very, very low speed data, and they piggybacked that data onto commercial satellite systems. And the commercial satellite owners knew nothing of it, because all it effectively did was just slightly increase the noise floor.
Yeah.
And some of that traffic was from organizations which we don't talk about.
Yeah.
And it only became noticeable if something went wrong with their experiments and they transmitted too much power, and then you suddenly see all this great lump of noise come up, and you think, anyway. So, but that sort of thing has always been possible.
Yeah.
But we never got involved in any. I'm not sure there were any experiments that went into deep space.
Right.
No. I mean, until they started launching deep space probes, the only people who looked into deep space were the astronomers, really.
Yeah.
But it's still until NASA and those sort of people came along and launched probes that were going to travel through the universe and out beyond our solar system, that you really wanted to talk to, or you wanted to.
Yeah.
I mean, I presume there were people out there listening.
Yeah.
Listening for the message. But I would have thought they were astronomers more than
Yeah.
commercial.
Because I mean, obviously things like Jodrell Bank, they're using it for a deep astronomy. Et
Yes,
cetera, et
yes,
cetera.
yes,
but,
yes.
But Goonhilly was presumably much more interested in commercial usage of satellites.
Yeah. I mean, we had. That's why the places like Jodrell Bank and stuff like that don't really have a transmit capability. They're listening.
Yeah.
I mean, they could add transmit capabilities. It's not difficult to do, but they weren't a commercial-based organization in that respect.
Yeah.
Whereas Goonhilly was always built as a commercial communications hub.
Yeah.
I mean, as far as I know, there's no money in talking to. There's nobody out there. There's no point in you're talking to yourself, really.
Oh yeah, yeah. I mean, I'm not suggesting that you were part of the SETI setup or the other one. What's the other one where you try and communicate with them?
Oh, I don't know.
METI, is it?
Is it?
But, yeah, I can't remember.
Yeah.
But because obviously recently Goonhilly announced that they were going to be part of the deep space network of.
Yeah, and you've talked to people already about that, and in other podcasts. But I mean, the nowadays in commercial satellite operations, commercial satellite operations are good for what they call point to multi-point. Fiber optics and cable is good for point to point. So, and you don't need. These days, with very large satellites, for very big capacities, you don't need huge great Earth stations. And stations like Goonhilly 1, Goonhilly 2 is already gone, Goonhilly 3 and Goonhilly 6 are historic pieces of kit. We don't need them that size at all. And they're expensive to run. Mm-hmm. You have to... as I say, it's all about getting value for money out of the equipment you've got, and they're really not value for money to run for that sort of commercial telecommunications anymore. You can get as many circuits over a dish a quarter size, 16 meter diameter. There's a few of those, 9 meter diameter. There's a lot more of those around now. Mm-hmm. In fact, that's mainly what has been constructed over the last 3 years at Goonhilly, is small antennas like that.
I mean, you can have them on the back of a van, can't
you? Yeah, you can. Yeah, I mean, if you look at the Avanti development at Goonhilly, that is all small dishes, higher frequencies, Ka band, but it's small dishes. So the market's gone on.
Yeah,
the business has gone on. But you've got Goonhilly 1. Which was the first antenna of that design, which all antennas around the world are built to now. You can't knock it down.
Yeah,
really. I mean, it's the history of the place, and it's in fact a listed structure now, so you can't knock it down. But if you're going to keep a still structure, which is basically what it is, still in concrete structure, you either cover it in something to protect it, or it'll fall down anyway.
Yeah.
Especially in the environments we got around here with the salty air. And if you're going to keep it in a reasonable condition so it stands up to the wind speed, you've got to paint it. Yeah. You just got to do basic maintenance on it. And basic maintenance on a thing that big costs a lot of money.
Yeah.
So you need to find something that those structures can do. To keep revenue coming in, to keep them in the way that people want them to be kept. Commercially, they don't make sense.
Yeah.
Commercially, it doesn't make sense at all to keep those structures. The best thing you could do is knock them down. But we got to keep them. So Goonhilly 1 is going to be part of going to be changed into a radio telescope. It won't have any transmit facilities. The corrosion problems with that antenna have reached a situation where the surface accuracy of the main dish is not as good as it should be for telecommunications operations, but it's okay for lower frequency L-band type optical, well, not optical, but astronomy type functions.
Yeah.
And that's what it's going to be repurposed to. Goonhilly 3, fine antenna. Not many of them, built by Marconi Company. Probably that one, Goonhilly 3, is probably the last one of that size they built. And of course, Marconi Company no longer exists. So that antenna is going to be repurposed again into a sort of deep space telescope, but it's going to be a telescope as well as a transceiver as well.
Right.
And there's a new feed being developed by transmission feed to take the signals that they're generated below and inject them into space. Going to be is being developed now by Oxford University, and it'll be a rotating feed that with a belt, and you flip around to different feed systems, so you can operate at different frequencies.
Mm-hmm.
I don't know where that development of that feed is, but I understand it's nearing completion, and it might even be delivered later this year. I'm not sure about that. So that antenna is going to have a major refurbishment, but not much significantly cost-wise, because that antenna is in very good condition. It won't need new drive systems. It won't need just a little paint around for a few rusty bits. Nothing significant at all. Might change the motors, because none of these antennas need to move as fast as they used to, so you can get by with smaller drive systems. And Goonhilly 6 is, as you already know, is going to be repurposed for a deep space communication system, and part of that refurbishment is to add extra communication bands over and above the C and KU capability that it's got.
Yeah, I mean, I absolutely love that wall of relay-based logic. Oh. Well, it just looks so impressive.
Yeah. Well, I mean, if we go back again, click the clock back. When I first went to Goonhilly, the transistors in the late 50s, early 60s, transistors were just, if you like, becoming something that we all knew about. And the room to control that antenna was in the main building, and it was it's if you've been to the site, you've got the tower, as they call it, like the aircraft control tower. And there was a room at the bottom of that control tower, much bigger than the control tower base, where there were probably 20 racks, and I'm talking about 9-foot high racks of equipment, with transistor boards after transistor boards because everything was done with discrete components.
Yeah.
There were no integrated circuits, as we know them today. And that took the information from the encoders, which was in gray code. I forget how many bits now, 32 bits, whatever it was, gray code, and converted them into angles. So to display, it took the commands from the console upstairs to drive the antenna. And they all went across site to the antenna site, a quarter of a mile away, over DC cables. But mainly we put relays on the ends of those, so that if there was, so you drive across, say at 28 or 30 volts, or 50 volts even, across the site, so that there were still some volts left when you got to the other end. And then there would be a relay then to take that information and drive it into the drive systems. But you needed relays because they were discrete disconnection points. So that if there was a lightning strike there,
it wouldn't blow
wouldn't blow the whole lot. And that was the way we had our lightning protection.
Yeah.
Eventually, of course, with photo-emitting diodes and stuff like that, you could do away with the wire. Yeah, but that was what gave us a certain amount of protection. The problem that really came was when you have a lightning strike of many thousands and thousands of volts hitting an antenna. It actually doesn't do any damage to the antenna. It just raises the earth potential of the whole of that area, which of course is connected by DC cables with 240 volts and stuff. So suddenly all your earth over there is hundreds of volts, and over here is at 0 volts, and you get great rushes of current down the earth.
Wow.
Yeah. So
that must be a major problem.
It was in the past, because you always got these earth loops, and it would pop transistors and stuff for a pastime. Always a terrible time when there was thunder and lightning. Nobody really wanted to be involved, because you always knew the next morning, but we're going to be so busy, trying to repair all these boards, because everything had to be repaired.
Yeah. And that's why I suppose you had those weeks off as well all that sort of thing. Yeah, because the life of a transistor was given in hours, not many thousands of hours as they are now. Yeah.
We put stuff in now that has got a mean time between failures of 155,000 hours. Well,
yeah, I suppose. Well, and again, that's the commercial push, isn't it? It's commercially made.
It's all about reliability. Yeah. I well remember when we first had the submarine cables started to land at Goonhilly. They went to Spain, and I was on shift with a friend of mine who was, because we all had our little departments. I was in the control room and the West Wing, which was where all the satellite stuff come in. A friend of mine, Mike, he was in the repeater station where all the stuff used to come in and go out to London. And when you have a submarine cable station, there's DC. You send DC down the submarine cable, but you have to have what they call an artificial line, which is the balance between the cable and the ground, and the actual power feeding equipment goes in the middle. So it looks, from an electrical point of view, is in the middle of the circuit. And we had a terrific thunderstorm, and the lightning struck the area of the ground, which was the artificial line, and that was capacitors and stuff like that buried in the ground, or made to look like that. And it struck this. I just opened the door because it was 11 o'clock and we were due to go off shift, 11 o'clock at night. And I just opened the door to walk in, and this lightning strike, I saw it go down through the wind, past the window, and hit the ground. And the rack, my friend was at the other side, and the rack between the two of us just exploded. It exploded. The doors came off, and there was this great, and for a second you couldn't hear anything, and then all hell broke loose. All these red lights just lit up the place on every rack. Every alarm in the place came up. One or two four-letter words were exchanged between the two of us. And I turned around and went and looked at my kit, and 3.5 hours later, we managed to get some semblance of services back working. But my God, that was some frightening experience. It really was.
Yeah, I can imagine. Yeah. Because it's quite an exposed part of the land, isn't it?
Yeah. Well, as I say, it doesn't do any damage to the structures. The only on the structures, what you have to watch is where you have a bearing point, like the elevation bearings. You have to have a strap that connects around the bearing, a big earth strap, a flexible copper cable, and you put that on all your bearing points, so that if when the lightning transfers down through you have a lightning rod on the top, but when the lightning goes down through the steel structure, if it comes to something that's like covered in grease, it could insulate it, and you could burn the bearings. So the that takes it around the bearings, and it just goes down into a big mat underneath the. I mean, when I say because they're you when you go to the antenna and you look at the concrete base that it's on, well, underneath that concrete base and out beyond the concrete base is a huge earth mat of copper wires.
Right. Yeah.
Spread about. I mean, they're not something you can dig up and steal. That's for sure. They're pretty deep. Yeah. You know, but there's big copper mats underneath all of those antennas.
I've definitely overshot here. So, have you got? Before I let you get on with your life, have you got any like really incredible story that is one of your favourite stories? You're allowed to tell me, obviously. That's about Goonhilly.
Well, no, not
favourite recollection. Or...
Well, actually, I mean, all I can say is about Goonhilly was I went there as I say, a loaney technician. I was able to use the facilities provided by BT as it became. I was on shift, and I hated shift work, and we had some fun on shift work. Some of probably best not to talk about, but I did. I was able to use the time when I was on shift to study, and I did my degree with the Open University. I was a B year student, so the year after it all started, and I did my degree courtesy of BT when I was working shift. So that was a great help. Mm-hmm. Thank you. And it gave me the life I got today without without transferring.
Yeah.
And then in the 90s, 92 to be precise, when BT was starting to downsize, shall we say?
Yeah.
Competition had been eating away at its superb profits. I was given the opportunity to take early retirement at the age of 48, a voluntary redundancy stroke early retirement, and I did, and I left. And I came home in that July. Said to Kate, this is the first day of the rest of our life. And on that Monday morning, when I should have got up, go to work, I didn't. I was laying in bed, and the phone rang at about 9:15 in the morning. And there was this guy on the phone from an organisation called BT Telconsult, an offshoot of BT. And he rang me up and he said, I hear you just left Goonhilly. I said, yes. He said, how would you fancy coming back as a consultant? So I said, well, I don't know, what's the first job? What do you want me to do? He said, well, I want you to come up to Slough and we'll have a talk about it. He said, but we're looking for somebody to go to Angola. Are you interested? I never even knew where Angola was. So yeah, and then that started another chapter in my life, which went on until pretty much I retired. And now I've gone back again, but back to the old job of looking at Goonhilly 1 mainly. So full circle for me.
Yep, absolutely. Well, yeah. So Goonhilly's been a major part of it.
It's been all my life. Yeah, really. Yeah, it's as I say, it's given me.
And you're a local Cornish?
No.
You got the Cornish accent there.
Yeah, well, I'm a Somerset boy. I was born in Bristol. But we lived in North Somerset, a place called Pill, where the motorway goes over the River Avon.
Right.
In fact,
I know.
Yeah, when I first heard about Goonhilly, I was a trainee in Bristol, and I used to go across Shirehampton. They had which is the other side of the river from where I lived. They had the regional training school, which looked after the whole of Devon and Cornwall, southwest of England, southwest region. And I was on a training course over at Shirehampton. I used to catch the ferry across the river to go to the training course. And there was a program with Raymond Baxter when they first showed the first thing, and it was on about midnight. And I stayed up to watch it, and that's when I made my decision. And I was late the next morning going to work because I overslept, missed the ferry. So there, that's what started it all for me. Yeah.
God, it's a good job you didn't miss that program, then, wasn't it?
Yeah, it was. Yeah, it was. Yeah.
Yeah. Thanks very much for giving us all that. That's brilliant.